Right, before we start the next thing, I just wanted to check and see if you can remember what the difference between a pure substance and a mixture is, and from there what a compound is, because we're going to look at some chemical changes which will involve some chemical reactions. So let's go back to when you have a pure substance, what does that mean? So this is a pure substance, or it's a pure liquid maybe, where all the particles can roll around and move around each other. Because they're all the same, we call that a pure substance. I've got different particles, different size, different colour, but they're separate from these particles, then they're called a pure substance. And when I throw them all in together, that's called a mixture. There's not enough energy for them to join, there's no reason for them to join, so they stay as a mixture. You know it's a mixture because you can separate separate parts from it. If they do join though, that becomes something we call a compound. You can have a pure compound. Now, not easy to join marbles and ping pong balls, but if I make them join together with glue, I'll never get them apart again, and join them together with something like cling wrap, you should still be able to see that I have my marble and my ping pong ball. I have my particles, but they're now joined. And if it's a chemical change, they're joined permanently. They don't separate apart easily. So that would be a pure compound. And I can make lots of these particles. And when you take particles and you make them join, you create something that connects them together. You put some energy in, join them. We call that a chemical reaction. We call that a chemical change. So this is a mixture. These are an example of something that's pure, but it's a pure compound now. I was going to try and name that compound. I'd need to know what the atoms were that were joined. And if that was carbon and oxygen, I might call it carbon as one of them, carbon monoxide. If it was copper and oxygen, I might call it copper oxide. So it depends what atoms are joined, what compounds you make, but a compound is still a pure substance. Right, so we're going to make some plastic, and it sounds like it's going to be complicated, but really plastic is just a compound that's made from a fat or an oil, and it's changed its structure, it's joined together in a different way, and the atoms that are there have joined in a different way. So we can make plastics from oil that we get from the ground, but we can also make plastics from oils or fats that you find in everyday things. What I've got here is a cup of milk, just regular milk from the fridge. Probably shouldn't use the UHT long life milk, that's not going to work very well. And what I'm going to do is add about 1/4 of a cup of vinegar to this one. And I tried it with lemon juice, and I also tried it just with heating before to see what would happen. You can see this one's filtering quite slowly, but at the bottom you can see the liquid, it's kind of watery, and at the top we've got like a thick chunky collection of white proteins. So this time I'm going to make the vinegar react with the milk, and I said I've got about 1/2 cup of vinegar. Some people like to eat this. If they do, they add some salt as well and to cheese. But what I'm going to try and do is dry out the plastic and then see what sort of properties it's got. How hard is it? Is it soft enough to bend or break? So when you first add your acid and you mix it, what you should see is that something happens fairly quickly to the structure of the mixture. And then you should start to see a change that's not going back to the way it was. So it's not that the layers are forming where you've got the vinegar at the bottom and the milk on the top, but you're actually starting to see lumps and chunks and some parts that can sink to the bottom. Now you probably need to stir it and wait a little bit, and then we're going to filter it. Now this time I'm going to use some cheesecloth as my filter. Cheesecloth is designed originally for separating cheese, and I'll set this one up here. So I've got my cheesecloth with my vinegar next to this one. Now what you should see is the liquid part coming off quite quickly. It depends what type of milk you've got, what amount of solid you're going to collect. If you've got something that's got low fat, it's got a lot less fat in it, not necessarily got a lot less protein. And the protein in milk that we're collecting is called casein. And if you can collect the solid and dry it out, it's been an old-fashioned way of making buttons. People used to use casein as a button for their clothes long before we had other types of plastics. What you should be able to see here is that it's got quite a lot of lumps and chunks and quite a lot of liquids coming out of the bottom. So I'll let that sit for a little while, and then when it's finished I'm going to collect as much of the solid as I can. Just leave that there. And then I'm going to put it into my mould and compare my different plastics. So what I want to do is compare how the lemon juice works with the vinegar. And I've got some strong vinegar here that I'm going to use. So although I've got 1 cup and I'm going to add some acid to it, I think I'll do it first with some lemon juice and second with some vinegar so I can compare them. So that would be my independent variable. Which type of acid gives me the most interesting or the best result? There's quite a lot of different cheeses. There's cheddar, mozzarella, camembert, blue vein, all sorts of types of cheeses. I'd like you to find in your group 4 cheeses that you'd like to look into a little bit more and research how they're made, and maybe compare what the differences is between them, because sometimes they're treated differently, sometimes different things are added to get more of that cheese out of the milk that they use. Maybe they use different types of milk. So I'm going to find out about 4 types of cheese and let everybody know about those 4 types. In a group of 4, you're going to choose 1 cheese, but the 4 of you will have 4 different types of cheese. Well, it's pretty challenging to get the plastic out of the milk. Maybe you'd like to have a go. You'll need to have about a cup of milk, and you need to have about a cup of acid, and then you'll need to make up some way of filtering it, whether it's with cloth or whether it's with some chucks, so that you can collect it at the end and dry it out. And I said it'll probably take 3 or 4 days to dry it out in the sun. If you want to try drying it out in the oven, don't use it too hot or you'll cook it. Right, now I've made quite a lot of plastic just using milk and vinegar. I'm going to leave it to dry and see how it looks in a little while. But remember, because it's only milk and vinegar, if we've used lemon juice, milk and lemon juice, just everyday things in your kitchen, it's pretty safe to make. Now if you're looking for some extra research and a bit more of a challenge, why not have a look at how other types of plastic are made? We've got quite a lot of plastics around us. We use them for all sorts of different things. Some of them have quite different names. We've got polypropylene, polystyrene, polyethylene, or polythene. So have a look at a different plastic, see how plastics are made, what is the reaction, the things that you start with, the reactants for the reaction. Can it be recycled and reused, or is the reaction permanent and can't use it again. Some plastics that people have been inventing are called biodegradable now. What do you think would happen with my Casein plastic? Do you think that would be biodegradable? Maybe you need to see what the word biodegradable means and research what plastics are biodegradable. Good luck with that.